Today's lecture is chapter 6, Weathering, Mass Wasting and Erosion. This chapter is very important and it relates to previous chapters. We started with in chapter 3 with plate tectonics, so we understood how the plates were formed, how they interact together. Chapter 4, we studied the geologic structures of these plates, how they change with time, or the final shape of them after millions of years. In this chapter, chapter 6, Weathering, Mass Wasting and Erosion, we are going to study what happens to these plates or to these layers included in these plates during time. As time passes, what happened to these layers or to these plates? Let's remember that we said that there is something called geomorphic processes. These are the forces that shapes the earth. We said that we have two types of forces: endogenic forces and exogenic forces. Endogenics, from the name, it means that it comes internally, from the inside of the earth. And we said that this is similar to volcanoes, earthquakes. This is forces coming from the inside of the earth, and when they come outside, they shape the earth. So this is called endogenic forces. We have also exogenic forces. These are forces coming from the outside, the effect of the atmosphere on the surface of the earth. So this is exogenic forces. Also, as a reminder, we said that endogenic forces are divided. In endogenic, the inside, the forces coming from inside. They are either fast process or slow process. Fast processes like earthquakes and volcanoes. And we said that there is something that you have all to take into consideration. We say that the internal process, the endogenic, they are constructive forces. How constructive? Because they construct the earth. They construct the shape, the final shape of the earth. But one of these fast processes is earthquakes and volcanoes. And we know that earthquakes and volcanoes are destructive. They destroy everything around them. So they are destructive to structures, but they are not destructive to earth. Once we have a volcano, it adds to the surface of the earth, so it is constructive. Volcanoes help in producing mountains, so it's constructive. From the geologic point of view, it is constructive. But from our building and construction point of view, it is destructive for our buildings. So this is something that we have to remember. So it's either fast process like earthquake and volcanoes, slow process like isostatic equilibrium and plate tectonics, which is the movement of the plates up, down, right, left, all plate tectonics, movement right and left. Isostatic equilibrium, movement up and down. But this takes millions of years to happen. So slow process formed the earth millions of years ago. A fast process adds to this formation every now and then. It adds something to this formation. What about exogenic forces? We said the exogenic forces are the forces coming from outside. This is what we are going to study now. Weathering, mass wasting, and erosion are all exogenic forces because they affect the surface of the earth. They are affected by outside. They are affected by wind. They are affected by rain, affected by floods. All of these are external forces shaping the earth. So what are these? These are called destructive forces because they destroy what endogenic forces has formed. Endogenic forces adds layers on top of the earth. Exogenic forces comes to remove part of this layer and take it away. So it is destructive forces. So this is called destructive. This is really destructive forces in terms of geology. Just to differentiate between these destructive forces and these destructive actions of the earthquakes and the volcano. This is something that you have to ignore now. We are now studying geology. So it is constructive in terms of the earth, and here we are going to study the opposite, which are the destructive forces. So those are forces that originate in the Earth's atmosphere. It comes from outside of the Earth, or derive their energy from the outside of the planet, also known as land weathering processes or forces, since they wear down the land because of their operation. What are the examples of these destructive forces or exogenic forces? Weathering, mass wasting, and erosion. Before we continue, let's just remember this rock cycle that we took when we were studying the chapter of minerals and rocks. This is the cycle that we have discussed, and I said that this is a very good presentation because it first gives you the three types of rocks. It's sedimentary, igneous, and metamorphic. What happens to these three types of rock? Look at these blue arrows. By weathering and erosion, so by destructive forces, by exogenic forces, they change into sediments. And these sediments, with time, they change into another form of rock. So weathering and erosion affects these three types of rock, and they are all types of rock. We have only three types of rock, so these three types of rock are affected by weathering and erosion. As we remember also, this was the same cycle, but in real time. I prefer to concentrate on this one. It is easier to understand. First thing is weathering. What is weathering? Different processes resulting in breakdown and disintegration of rock in place. Similar to the example that we have said before, if I take a piece of food and leave it on a table for a week, after a time I will find that this piece of food, it will disintegrate. It will stay in place. Nothing will happen. It will be in place, but if you just touch it, you will find that it is like vaggy from inside, lots of voids inside and something like this. What happens? It disintegrated. The inner constituent of this material vanished. So this is what we call weathering. So weathering change due to breakdown and disintegration of the material, but in place. There are two types of weathering. It's either mechanical weathering or chemical weathering. Mechanical weathering, when physical forces break down into small pieces without changing the rock mineral composition. It's the same rock, but due to maybe wind, due to any other climatic, maybe because of heat or whatever. So because of external forces, it disintegrated, but the mineral itself is the same. Nothing has changed. There is another type called chemical weathering. In chemical weathering, breakdown happens, but the breakdown will happen due to chemical action between the main constituent of the material and other materials from outside, or even from constituents, they interact together to form this kind of disintegration. So it is due to chemical process. Let's study each one. Mechanical weathering. Mechanical weathering has 4 types. Frost wedging, so the first type is due to frost. The second type is thermal. The third type is called unloading and exfoliation. What is exfoliation? Exfoliation in Arabic, تقشير. The material changes. I just take layers from on top of it, like having a fruit in your hand with a knife, and then you take slices. So when you take slices, you as if you're exfoliating this fruit. So exfoliation is layers leaving the main rock and going and disintegrating. The third is biological activities. Let's study each one alone. First, frost wedging. This is the first type of mechanical weathering. How this happens? Imagine this is a block of rock with crack or cracks. What happens when water comes inside? It is full of water. The crack is now full of water. Then temperature goes down, 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 till we reach maybe 4 degrees and below. You know that water, when it reaches 4 degrees, the volume expands. If you don't know this, just take a bottle, fill it with water, plastic bottle, put it in the freezer. What will happen to this bottle after it is freezed? You will find that suddenly it is as if it's going to explode. If you put a glass bottle, it will break down. Why? Because it was full completely with this certain volume of water, but once it reached 4 degrees centigrade, the volume increased, so it wants to expand. So this is what happened. Here, water is filling this place. Once it expands, it has to push the edges of the crack. By the way, do you know why this happens? Why water increases in volume? Of course, this is not the only reason, but one of the benefits of water increasing in volume is, in the seas and the oceans, in the North Pole and the South Pole, what will happen to fish inside the water? It will freeze? No, it does not freeze. So what happens? What happens is that we all know that the inside of the earth is hot and the outside is cool or cold. At the North Pole, it is below 0. So if this condition stay as it is, it will end up freezing the whole ocean or freezing the whole sea. So what really happens? What happens is that when water reaches the top layer, when it reaches temperatures, say we are in summer, temperature is 10 degrees, then it goes down, down, down. Once it reaches 4 degrees, the volume expands. So what happens is that there is a change in the density of water. So water starts to move in cycles. The top part goes down and the lower part comes up. So the lower part is still hot. It goes up to replace a layer that is very cool, and it is about to freeze. So this cycle keeps living organism inside the water without being freezed. So it is something very, very important for creatures living in the sea. But what is the effect here on this? Is that once this amount of water freezes, it wants to expand. Once it expands, it pushes the side. So if I have a small crack, next year it will be bigger. And the following year it will be full of more water, and the more water want to expand, so it pushes again, and so on. Each year, freezing, thawing. So what will happen in the end? That the crack is going to increase. So this is just an explanation, and this is how it is in real life. In real life, all of this was just one piece of rock. So it started to break like this, but what we are interested in is this gap, this big gap and this small gap. It is because of frost wedging. So this is what we call frost wedging. The second type is called thermal expansion. Thermal expansion, from the name, it is due to cooling and heating. In the morning, I have the sun, it is hot. At night, I have no sun, so it is cold. So every day, I have the upper part subjected to cooling, heating. So what will end up? I will end up cracking the top layer. So when I crack the top layer, with time, the top layer is going to break down into pieces and fall down. So this is what we call thermal expansion. So it is mechanical weathering due to thermal expansion. This is the shape in normal life, and this is an explanation for that. The third type is called unloading and exfoliation. Imagine that I have this. You remember when we were studying plate tectonics and something like this, we said that magma is stored inside. So I may have a deep layer of igneous molten rock. This will be like this, and it is covered with just any other type of rock. With time, the upper part of the rock, of this sedimentary rock, disappears with time. So it ends up having this shape. What is this shape? I have here a type of rock. It is as if it is uplifted to the ground, and I have around it another type of rock. So this type of rock, which is igneous rock, what will happen to it? It will be exfoliated. How it is exfoliated? It means that I will have the upper part. It is, by the way, similar to what is happening here, but this is a little bit stronger. This is something very weak, just thin particles, but this I have similar to what you see in this photo. Strip, a very big layer, just shattered away on top of this big mass of rock. So this is unloading. First, there will be some kind of unloading so that the surface layer would be removed, and once it is removed, this layer, this curved shape, stay in place, and with time it is affected by exfoliation. The third type is called biological activity. So the fourth type of mechanical weathering is biological. What is the effect of this biological? How it happens? It happens due to two things. We said it is biological, so it is either due to animals that live in the ground. They can dig holes and passages inside the earth. So this is a biological activity that affects the weathering of the material, or it may be because of the roots of the plants and trees. So this is a shape of something like this. This is a tree just separating two pieces of rock away. Chemical weathering. You see from the shape, Just see the shape of the rock and you will know that it is chemical. This rock, it is as if it has holes and vagi from inside. That what happened? It happened due to some kind of chemical reaction. It is either chemical reaction between the constituents of the rock or from the rock and the outside environment. So with time, I find that I will have gaps and voids and so on in this rock. So this is chemical type of weathering. This is another type. This is a cave. By the way, this photo is in Lebanon. It's a very famous place. I think it's called Jetta cave or something like this. People go and visit this place. So if you go inside, you will find this shape. What is this? It is the rock is weathering and the cave is increasing inside, and this is just the remains of what is there, or just pieces or water or salt just coming from the top of the cave. This is a description for this chemical weathering. What is important is that we see that from this. Here it's written limestone. Limestone is a very famous type of rock, and it is found a lot in Egypt. So being a geotechnical engineer or a geologist, you should know what is limestone and what is the properties of this limestone. This is very, very important, because limestone, it's a stone. You know what's limestone? الحجر الفرعوني. You know, all in any place, if you go, sometimes you find cladding, buildings covered with white stones, pieces of stone outside of the building. It's found in the north coast a lot. Many buildings are cladded from outside with this limestone. Limestone is a rock, but it is not that strong. It is a little bit soft. So this limestone is also affected by water. Maybe after millions of years, this limestone, with the effect of water, it makes passages inside, and these passages may be caves. So this is what happens. Imagine that this was all limestone. With time, water comes inside in any crack, and with time this crack increases till it is like a cave inside the rock. So why it is important? Because if you go to any place and you start your site investigation and you find limestone, you have to anticipate that maybe in your borehole the limestone was intact. Imagine that you took a borehole here at the edge. It will be intact from top to bottom. But it means that in another place like this, you may have a cave. So if you go in a place and you find limestone, you have to increase your site investigation to confirm that this limestone did not reach the condition where I may have caves inside this limestone. Of course, it depends on the region. Are there rain? If limestone is found in a very dry condition, it will be a good limestone. But limestone with water, it means that it is possible that it would be disintegrated in some places, and caves are there. Caves mean if I put my building on top of it, it will fall down. You remember the photo of the building in a place called Guatemala? I showed you at the beginning of the course. Building collapsing down due to the effect of something called sinkhole. What is sinkhole? Sinkhole is the effect of an inside cave that collapsed from the top, so everything on top fall down inside this cave. So if this is the cave, then here this is sinkholes. Just because there is a cave inside, so you will find few sinkholes on top, and these sinkholes may collapse suddenly and taking everything on top, especially if you have a building. If you don't have a building, it will take time, but if you put additional load, it will take this additional load and fall down. So it is very important. So this chemical weathering with limestone and in the presence of water is very important for us to understand. What are the factors affecting weathering rate? This is also important. Will weathering happen very quickly in all rocks or very slowly on all rocks, or it depends on many things? What does it depend on? Of course, without thinking, rock hardness. Hard rock will take a longer time to weather. Exposed rock surface. If I have rock below ground and I have rock on top of the ground, the rock on top of the ground will weather quickly. Climate, as I said before, if I have water or I have a dry condition, if I have just a dry place, then weathering will be slower. Let's take each one. Rock hardness. This is just for you to remember. This is the figure that we took before in the lecture of the minerals and rock, if you remember. So in this lecture, we studied something called rock hardness. Rock hardness, it starts from 1 for talc, and it increases till it reaches 10 in case of diamond. Of course, if I put a diamond ring millions of years, it will not be affected because it is diamond, it is very hard. But if I take a piece of talc and leave it for a period of time, it will be affected by weathering. The other thing is called the exposed surface. If I have this, imagine that you have a block like this, 2 by 2. What is the time needed for it to weather? It will be very big. But if this piece of rock is divided into 8 pieces, what will happen? It will take less time. If it is divided into more pieces, it will take less and less time, and so on. So cracking in rock help in increasing the exposed surface, and because of this, weathering will happen quicker. Climate. As I said, climate depends on 2 things. I said before the water. Water comes from precipitation, from rain. It also depends on the temperature. High temperature helps in increasing the weathering condition. Good climate, it is okay. Think of it, if I have high temperature, it means that the variation between high temperature and low temperature will be a lot. So cracks will happen. Cracks will happen. It means the surface area will increase. So temperature is a factor that helps in cracking the rock. And by cracking the rock, I am facilitating the weathering condition. So this is a graph between the temperature. Here 30 degree, here is minus 20. Here is the average yearly precipitation, the amount of rain. This is for the amount of rain. So this is this dotted line is just, or dashed line is the line, the maximum that would happen. Yani you don't have rock here. There is no possibility of weathering here. All the weathering happens below. So the maximum I have is this point. This point is the maximum weathering condition. What is the maximum weathering condition? Very high temperature with very high amount of precipitation. This is the minimum amount of weathering. Zero precipitation with the least temperature possible. So in between I have here different shapes. This is just for you not to memorize this figure, but just to know that the maximum happens when you have very high temperature with very high amount of rain, and the opposite happens and vice versa. How to prevent weathering? To prevent weathering, is there a possibility to prevent weathering? Geology defined the problem. Now we know the problem. Geotechnical engineering can provide solution for this problem. But do we need to prevent weathering? This is one question that we have to answer. Do I need to prevent weathering? Sometimes I need to prevent something for my structure to be safe. But let's take weathering. Before taking weathering, just we have to check this, what I'm going to say. When I should prevent a geotechnical problem, I should prevent a problem in case, or I should not. When should I say I'm not going to interfere? I'm not going to do anything. Why I will do nothing? Because the problem is very big. If I tell you that I want to build a building on top of a volcano, you will tell me no, I cannot do this. This is beyond my capability. I cannot put my building on top of a volcano. I don't have the engineering tools to help you put your building on top of the crater of a volcano. This is so. If the problem is extremely big beyond the limits of human beings, I cannot do anything to this. I will tell you, change the location of your building. The other thing, if there is no need to intervene, I don't need to do this because the problem for me is minor and I can live with it. So weathering is a very long process. It takes very long time. For something to weather, it would take maybe million years, hundreds of years. But what is the lifespan of my building? If I build a building, how many years this building is expected to live? 100 years? This is the maximum. This is the maximum design value for any building. So during this 100 years, what is the effect of weathering of the rock on my building? Nothing. Approximately nothing. So weathering is a very long process. It takes much longer than the lifespan of the structure. Therefore, we will live with it. We are not going to interfere in this problem. So any type of weathering, I just have to consider that there is a possibility of weathering. But how I'm going to take it into consideration? I will say that my building may settle 1 centimeter more than my design value. Why not? 1 centimeter more than my design value. I can live with it. My building is not going to fall, but I have to take it into consideration. The next part will be the second thing, which is mass wasting. I will put it in a separate part of this lecture. We can end this part at this point and continue in the next part.